Okay, so we have started something called computer vision. Okay, computer vision hands-on series. Okay, hands-on series. Guys, if you're looking for any kinds of computer vision related data, you can check this RoboFlow Universe platform. So here you will be getting all kinds of computer vision related data, whether it is object detection, image classification, instance segmentation, key point detection, semantic segmentation, all kinds of computer vision related data are available. Even if you see this data, actually this data is already annotated, so you can download the annotation with respect to YOLO 11, YOLO 10, YOLO v9, okay, even TensorFlow, PyTorch, all kinds of format you can save the data. So this is one amazing platform, guys. It has all kinds of computer vision related data, because we know that inside computer vision, data annotation is the very costly task, right? So first of all, try to check here if you have the dataset or not. Okay, the dataset you are looking for. So to download the data, just click on that data, and here you will get one option called download project. Just try to click here. After that, you will see one option called download dataset. Okay. Now, if you don't have the account, please try to sign up with your account. So let me sign up with my account. Okay. After that, you will see this option. Now you can select the format. Okay. In which format you want to download the data, and simply select this option, download as a zip file. Either you can also download as a code snippet. So you can select this option and click on continue. Okay. So I'll select, let's say I will select YOLO v8. Now if I continue, so it will download the data. Okay, so that's how easily you can download any kinds of computer vision related data from this RoboFlow universe. So here we'll be like mainly focusing on the practical implementation. So first of all, we'll be starting with the image classification. Okay, image classification. Okay, so if you have already learned about, let's say, CNN, okay, convolutional neural network, CNN. So in CNN, you will see the first task actually you have to perform something called image classification. So you can either create your custom architecture, either you can use like pre-trained models. Okay, pre-trained models is also available, which is trained on this particular ImageNet dataset. Okay, ImageNet dataset. So this is like benchmark dataset. They have trained different model. Let's say we have VGG16. Okay, VGG16. We have Inception. Okay, Inception. Then we have ResNet. Okay, we have ResNet. Then we have MobileNet. Okay, we have MobileNet. Then we have DenseNet, and so on. Okay, there are so many models you can use, and these are the pre-trained model. Okay, so this model is already trained with ImageNet dataset. So what I can do, I can like apply something called transfer learning, and I can download these at the model weights. Okay, on top of that, I can train my custom data. Let's say you are having a different dataset. Let's say you are having a dog cat dataset. Okay, dog and cat dataset. So basically you want to also add this particular, let's say, label in your model, so that your model can also predict, okay, whether it's a dog or whether it's a cat image. Okay, so for this, what you have to do, you will be picking up this particular base model. Okay, the model actually which is trained on ImageNet dataset. On top of that, you will be training your data. Okay, the dog cat data actually we are having, and that is called actually fine tuning of the model. Okay, so we are applying transfer learning because it is already know, we are just transferring the learning, okay, in the model itself. So this is called transfer learning. So we'll be following these are the approach only, because nowadays nobody creates their custom architecture. If you're creating your custom architecture, so definitely you won't be getting good performance from the model, and you have to train like you can say lots of epoch, and you should have lots of data for this. Okay, but as a developer, we don't have that much of time. Okay, if you are going for the research purpose, at that time you can like work with this particular custom architecture. So let's say if you want to bring a architecture which would be better than, let's say, VG16, so at that time you can design your architecture, you can propose a paper on top of it. Okay, but again you have to use this ImageNet dataset. You have to use this particular ImageNet dataset to evaluate your model, whether this model is performing okay, better than the VG16 model or not. Okay, you have to prove that. Okay, for this you have to publish a paper. So that's why actually over the internet you will see people are coming up with a new let's say architecture. Okay, nowadays, and they're publishing a paper on top of it, and they're claiming that this model is performing better than this model. Okay, so that's how actually, if you are going for the research purpose, if you want to work with the custom architecture, you can use it. Otherwise, as a developer, what you have to do, you have to go with the pre-trained model, whatever model actually we are having. So we'll be downloading the weights of the model, and on top of that we'll be training our custom data, and we'll be building the application on top of that. Okay, so this is the idea. Right. Now the second task actually we'll be exploring, called object detection. Okay, object detection. So this is like very used task actually over the industry, object detection. So if you see any company, those working, are working with this particular computer vision domain, so they will be working on this particular object detection task. Okay, so in object detection also you have so many, let's say, tools and technology, so many algorithms are there also. So we usually use something called faster RCNN, okay, SSD. So these are the model architecture we'll be using, okay, for the object detection task. I'll be also discussing these are the thing like what are the framework, okay, we can use, how we can get the, let's say, pre-trained model, okay, how we can train on top of our custom data, and how we can perform object detection in real time. Everything I'm going to discuss. Then after that we'll be also discussing something called we'll be discussing object segmentation. Okay, object segmentation. So this is another very powerful application you can talk about in the field of computer vision, because currently actually I'm using one object segmentation, let's say, tool. Okay, because see, I'm using this particular let me show you. I'm using this particular NVIDIA Broadcast. So here in the camera, actually, if you see, I have added my virtual background. Okay, in the camera, I have added my virtual background, but how it is applying this particular virtual background? Okay, because it is segmenting out. Okay, it is segmenting out me as a person and my chair, and rest of the thing it is removing. Okay, and there actually I can add this particular virtual let's say background. Okay, so this is one like one good application of this particular object segmentation, because it is segmenting out me and my chair, and rest of the thing it is removing. Okay, so that I can attach any kinds of image here. Okay, so there are so many like application you will find over the internet of this particular object segmentation, but this is like most used actually task. So this particular technology you are using with your Zoom, with your Google Meet, okay, any kinds of, let's say, a video conference, let's say, platform you are using, everywhere you will see people are using object segmentation to segment out that particular object, that means the person and chair, and rest of the thing it is removing, okay, as a background, and you can attach any kinds of background with that. Got it? So we'll see like how we can perform object segmentation, and we'll also learning like how we'll be training our own object you can say segmentation model on top of our custom data with the help of this pre-trained model and all. Okay, and mostly we'll be using in the object segmentation mask RCNN model. Okay, mask RCNN model. Okay, and in object detection we'll be using faster RCNN and SSD, that means single shot detector. And in image classification I'm going to use, these are the model VG16, Inception, ResNet, MobileNet. So if you can learn only one implementation, rest of the thing you will be implementing. I will tell you, I will give you the guidance, okay, how to select different model. But in this particular video I'm going to use something called VG16 model. Okay, VG16 model I'm going to use. Okay, yeah. Then after that I'll be also discussing something called object tracking. Object tracking. What is object tracking? Object tracking means it will track the object. Let's say in object detection we only can let's say detect the object, but when it comes to the real time tracking, okay, I think you have seen like there are so many organizations they're using this particular object tracking system. Let's say you have one big construction okay, industry, so there are lots of trucks and let's say a vehicle is coming. Okay, so what they are doing, they're counting that the vehicle, like how many vehicles are coming, how many vehicles are, like, let's say, moving. Okay, that's how they're making the count. But how they're making the count, they're tracking that particular object. Okay, real time they're tracking. Even nowadays in sports industry also people are using object tracking. They're tracking the player. Okay, they're tracking the ball. Okay, that's how they're performing. These are the tasks on top of it. So we'll be also learning how we can perform object tracking in real time. So for this actually I'm going to use something called deep sort. Okay, so deep sort is a object tracking algorithm, state of the art algorithm we'll be using. And for the object detection I'll be using YOLO. Okay, YOLO v5 I'm going to use. So whenever you are performing object tracking, first of all you have to detect that particular object, and after that you have to track that particular object. Okay, for detection you will be using YOLO v5, and for tracking we'll be using deep sort. Okay, that's how actually we'll be covering. Yeah, then I may also discuss about GANs. Okay, generative adversarial neural network. I think you know that, generative adversarial network. So GANs I'll be also discussing. We'll be seeing like how we can generate like a new image, because nowadays like this is like very powerful application you are using in the field of image generation. So nowadays lots of LLM came, right, large language model came also, with the help of that you can generate an image with the help of prompt. If you give any kinds of prompt, it will generate the image for you. Okay, so we'll be also learning the mechanism behind GANs. Okay, how we can develop a GANs, our own GANs, and how we can use this particular GANs algorithm to do different tasks. Let's say you want to perform super resolution. Let's say you have one image which is like very less, low resolution image. If you want to convert it to high resolution, you can use GANs. Okay, for this. So that's how actually there are so many GANs are available. Okay, you can use, and I'll also like give some brief idea about this LLM, like how LLMs uses GANs and all. Okay, to generate these are the images and all, right? So yes, these are the tasks actually only available inside computer vision. Okay, if you know these are the tasks, I think it's enough for you. Okay, now you can perform any kinds of, let's say, task, or you can solve any kinds of problem statement. Okay, in industry. Yeah, and apart from that, if you need anything, let's say you want to learn this particular technology, you can comment out in the description, or let's say you can comment out in the comment section, so that we I can look into it later on, and I may come up with that particular series also. Okay, so you can let me know. Yeah, because I was getting lots of queries related to this particular computer vision, whether we are having computer vision related job role or not in the market. So definitely there is a job role, but the thing is, like, you have to master these are the technology. Okay, these are the you have to master these are the tasks, and if you have some good projects, okay, on top of it, definitely you will get a job. Okay, because companies are also using computer vision, companies are also using NLP. Okay, they're also using machine learning, deep learning, everything they're using. Okay, it's not like that. Let's say currently generative AI came, all the companies are working on generative AI only. It's not like that. People are also working on computer vision because their company is related to computer vision only. Okay, so there are lots of, let's say, computer vision engineer would be hired. So definitely you should have a good profile, you should have a good skill set. Okay, definitely you will also get a job, right? Yeah. So yes guys, this is the complete agenda for the entire actually series actually we'll be covering. Okay, so today actually I'm going to perform this image classification, okay, with the help of TensorFlow. And mostly tomorrow we'll be showing the PyTorch implementation as well, like how we can use PyTorch as well. Because people are also telling, like, sir, I know the TensorFlow implementation, but when it comes to the PyTorch implementation, so I get difficulties. Okay, so I also need to explore the PyTorch. So that's why I'm thinking to also show you the PyTorch implementation, so that you can also use PyTorch apart from the TensorFlow. Okay, yeah. But what I feel like TensorFlow would be a little bit easy to implement, because Keras has been integrated with TensorFlow right now. Okay, so that's why actually Keras has actually high level API, so you can like import all the functionality as a high level, and you can perform these other jobs. But whenever I'm talking about PyTorch implementation, so there actually you have to write low level Python programming. Okay, so that's why some implementation actually will get difficulties. But again, I'll give you the understanding, so things would be very much clear. But if you want to understand the PyTorch code, definitely you should have knowledge on this particular OOPS concept. Okay, in Python, object oriented programming. Okay, if you have this OOPS concept, so definitely you will understand the PyTorch implementation as well. Okay, yeah. Now one question would be in your mind, so what is the difference between image classification, object detection, object segmentation, okay, and object tracking? So for this, I'll show you one particular image, so your understanding would be clear. So here I can write search about difference, okay, between object detection and image classification. So there is the image actually we'll get from the Google. So let's say I'll pick up this particular image. So let me just show you. Yeah, so this image actually I can take, I'll copy, and here I can paste on my board. Yeah, so here you can see we have three different images actually. The first image is telling it's an image classification problem statement. Okay, why it's image classification problem statement? Okay, if you see here in this particular image, we have one particular object only, which is nothing but dog. Okay, now this image classification task will tell you whether this image is a dog image or it's a cat image. Let's say you are having one cat here. Okay, instead of dog, that time it will tell you it's a cat image. But whenever you are having dog image, at that time it will tell you it's a dog image. But you can't see it. It will detect that particular object. Okay, I can't see the detection. But whenever I'm talking about, let's say, both, okay, cat and dog in the same image. Okay, so what will happen actually at that time? If you're using image classification, it will fail, because it can see actually both images are present in that particular image. Okay, so that's why it will fail that time. So that's why actually instead of applying image classification, we perform something called object detection. So object detection, what it will do, it will detect that particular object. Let's say this is a cat, okay, and this is a dog. That's how it will detect separately. Okay, it will detect separately, this is a cat, okay, and this is a dog image. Okay, so this is called object detection because it is localizing that particular object in that particular image. Okay, then there is another task called image segmentation. Okay, as I already told you, it will segment out that particular object and rest of the thing, okay, it will remove. You can either remove, you can either keep, it's up to you. But the thing is like it will mask. Okay, it will mask on top of this particular object, as you can see. Okay, it has applied this masking. Okay, it has applied this particular masking. Okay, this is called mask. So you have to also apply this masking, and after masking actually you can segment out that particular object. Okay, so this is called image segmentation task. Okay, and what is object tracking? Object tracking is nothing but you will detect that particular object. After that you will track. Let's say this dog is moving. Okay, this dog is moving. Let's say this is the position 1. Okay, this is the position 2, this is the position 3. Initially let's say this dog 1 on the position 1, so you have to track this dog here. Let's say whenever this dog will move in the position 2, okay, again you have to track this particular dog. Let's say this dog will move in the position 3, okay, you have to track this particular dog. So this is called object tracking. Basically you are tracking real time. Okay, you are tracking real time of this particular object, so we call it as object tracking. Okay, so these are the difference between image classification, then our object detection, image segmentation, and object tracking. Okay, and I think you already know about GANs. Okay, that means generative adversarial neural network. We can generate like you can say new data with the help of GANs. That means we can generate an image. Okay, nowadays actually diffusion model is there also, so it is like very powerful model. With the help of diffusion model also you can generate an image and all, right? Yeah, so this is the like idea of the entire series. Actually, I hope you got it. Now we'll be starting with the implementation because this is a hands-on series. Actually, I'm not going to discuss about the theory, how this image classification, how this like CNN works and all, right? So for this, I am expecting you already have the basics idea about image classification. Okay, this convolutional neural network and all. Okay, then you will be able to understand this particular practical series. Okay, yeah. So for this, actually, what I'm going to do, I'm going to open up my Google Drive. Okay, so you can open up your Google Drive and you can create a folder. So I have created a folder called YouTube Live and CV Hands-On. Okay, so here what I will do, I'm going to create a Google Colab. Okay, so let me create a Google Collaborative. So in the Google Colab, actually, we'll be performing all the codes. Okay, so let's name this particular notebook as image classification. Okay, image classification using TensorFlow. Okay, so TensorFlow is a like framework, deep learning framework. I think you already know about TensorFlow. So it has implemented by Google team. So TensorFlow. Okay. So this is the official like website of the TensorFlow. So we'll be using this particular TensorFlow API. So here actually we'll get Keras integrated. Okay. Previously Keras was a separate actually framework, but they have collaborated together. They have integrated this particular Keras with the TensorFlow. Okay. Now I can access like Keras from the TensorFlow itself. Okay. And with the help of this particular TensorFlow, we can do all kinds of tasks. Actually, you can perform image classification, object detection, okay, object tracking, anything you can perform. But we'll be exploring different tools and technology because we won't be relying on one particular tools and technology, because in the industry people are exploring all kinds of technology, all kinds of framework. Okay, so you should also have the idea on top of it. So you can go with the documentation, like how to install this TensorFlow and all. Everything they have given the guidance and all. If you're using local system or whether you are using Google Colab and all, let's say if you're using Linux, Windows, okay, Mac OS, anything you can use, and you can see the guideline of the installation. Okay, but whenever I'm talking about, let's say, Google Colab, so by default actually TensorFlow comes with like installation here, so you don't need to install separately. Okay, so if you want to test it, so first of all, what you have to do, just select the runtime as GPU. So let me select the runtime as GPU, because here I'm going to train my model, so definitely you should have GPU configuration machine. Okay, otherwise if you're using CPU, so it would be very you can say slow training. Okay, but I don't want that. So if you're using like free Colab, so you will get this particular like T4 GPU. Okay, T4 GPU is there. But if you're using paid Colab, so you will be getting this A100 GPU and B100 GPU. Okay, so I'm using this Colab Pro, so that's why I have this particular premium GPU. But if you're using free Colab, you can use this particular GPU called T4 GPU. Okay, it's completely fine. With the help of T4 GPU also you can perform the training. Okay, now I have my pro access, so I'll be going with this particular V100 GPU. Okay, I'll also select the higher RAM and I'll save the instance. Then after that, I'll just connect this particular notebook. So once it is connected, I'll import this particular TensorFlow here. Then I can start the further implementation. Okay, so they have already written, give you the guidance and all, GPU device plugin and all, everything you can refer from here. Okay, now it is connected. Now what I will do, first of all, I will check whether I am having this particular TensorFlow integrated or not. But before that, if you want to test the GPU, whether it has integrated GPU or not, you can execute this particular command. So let me zoom this particular screen a little bit. So you can write NVIDIA, okay, NVIDIA -SMI. So this is the command to check the GPU instance, whether you are having GPU or not. So see guys, here I got Tesla V100 GPU and it is having a 16 GB VRAM, okay, because it's a premium GPU. But if you're using T4, it will have, I think, a 12 GB VRAM, okay, mostly. I don't know. Yeah. Okay, now let's import TensorFlow and see whether I'm able to import or not. So here I'm going to write import TensorFlow. Okay, TensorFlow as TF. Okay, so you can give a nickname of this particular TensorFlow, because every time you don't need to call this TensorFlow name, you can name it as TF. Okay, TF means TensorFlow. Now if I execute, so it should import my TensorFlow because it is already installed in my Google Colab. But if you're using in your local Jupyter Notebook or VS Code, you have to install it. Okay, and installation guideline you will get from the documentation itself. Got it? Now see guys, execution is done. There is no error. That means I'm able to import this particular TensorFlow. Now if you want to check the version, okay, version of the TensorFlow, you can just write tf dot hyphen version. Okay, hyphen. So if I execute now it will show me the version. Okay, so currently TensorFlow actually is like 2.15.0. Okay, this is the current version. If you want to verify, you can go to the PyPy. So TensorFlow PyPy. Okay, so PyPy having all the hosted package. So TensorFlow is also there. Now if I go to the release history, okay, so 16.1, but in Google Colab it is installed 15.0. Okay, no issue. You can either install 16.1. Okay, this is the current, and the release date is March 9, 2024. Okay, but I'm using 15.0. I think I'm using 15.0. So 15.0 is there. The release date was like November 15, 2023. Okay, so if you want to, let's say, install this particular TensorFlow, just click here. This is the command you need to execute. Okay, in the Google Colab. Okay, in the Google Colab, you have to execute this particular command. Then you will be able to install this particular 2.16.1 version. But I won't be recommended, because whenever they comes with, let's say, the latest version of the package, so definitely some issue would be there. So I'll suggest go with the previous version, because in the previous version it is already stable version, people are already using, so you won't be getting any kind of difficulty level. Okay, yeah, so that's how actually we can check the version, okay, of the TensorFlow. Even you can also check the version of the Keras. So here I can just write from TensorFlow, okay, import Keras, because Keras is already having inside TensorFlow, so I can import Keras. Now if you want to check the Keras version, just write Keras, okay, dot hyphen version hyphen. Okay, you can also check the Keras version. Okay, so Keras 2. Has not attribute version. So let me check how to check the version of the Keras. So maybe I will get the code of the Keras. Just a minute. TensorFlow. Yeah, so this is the code, I think. Now I'll go back, and here I'm going to replace. So TF. So I don't need to import it, I think. Can remove it. Now I think this will give me the Keras version. Okay, so I'm not getting. Let me see. To print the Keras version, import Keras. To print the TF version, import TF. Okay. Let me go to the Stack Overflow and see that. Yeah, you can also directly import keras. It is also possible. So let me show you. So here I can write import keras. Okay, now we can check the keras version as well, because again it is coming from TensorFlow itself. So no need to import. So here I can write keras dot hyphen hyphen version hyphen enter. Now see guys, it is also 2.15.0 because it is using 2.15.0 this particular TensorFlow version. Okay, that's how you can check different version. Okay. Now let me show you the data set actually I'm going to use for this particular image classification task. So this is a simple data set, guys. This is a dogcat data set I'm having. So that's how actually you have to prepare the folder. So in the data folder, you have to create two folder. One is like training, okay, another is like validation. Okay, as you can see, another is like validation. So inside training, I kept my training images. So first of all, you have to create a folder called dog. Inside that, you will be keeping all the dog images. Okay, see, these are my dog images, and I'm having 168 dog images here. Okay, it's like very less images for the training, but this is a live session. I just need to show you the training. That's why I kept less images. But if you want to train a good model, so definitely you should have use lots of data here. And where you will get this particular data? This data set is available in the Kaggle. Okay, if you just go to the kaggle.com, you can search about dogcat data, Kaggle. Okay, so Kaggle is having lots of repository, so you can download the data from there only. Okay, so let me show you. See, dog versus cat data are available, and here is the data, guys. So if I click on the data, and here you can download. See, here you can download this particular data, and it's around 853 MB because it is having like lots of images. Okay, so you can download this particular data if you want to train a good model. Okay, but what I did, I just kept some of the images here. Okay, in the training, that means in the dog folder as well as in the cat folder. Okay, these are the cat images, as you can see. Okay, now similar wise, in the validation folder, I created dog and cat folder. Okay, and inside that I kept my dog image and I kept my cat image. Okay, so that's actually you have to provide the label. Okay, you have to provide the label of the model. Okay, so what is happening here? So let's say here I created the folder like that. So first of all, I'm having one data folder. Okay, I'm having one data folder. Okay, now in this particular data folder, what I'm having? Okay, I'm having two folder. One is like train. Okay, another is like validation. Okay, so inside train. Okay, inside train. So here I can yeah, so just a minute. I think I can write like that. It would be good. Yeah, inside train, I'm having two folder called dog, and another is like cat. Okay, cat, and inside that I'm having the images. Okay, all the images inside that I'm having all the images. Okay, images. Okay, then I have another folder called valid. That means validation. Okay, inside validation also I'm having two different folder called dog and cat. Okay, and inside that I have my images. Okay, so what is happening actually? So whenever, let's say this is my model. Okay, this is my model. So whenever you are giving this particular image as an input, let's say this image will go as an input. Okay, and how your model will get to know, okay, whether it's a dog image, because see, you have already given the folder name. Okay, it will take this particular folder name as the label. Okay, it will take the folder name as the label. So that means this is the y, this is the y. Okay, y, that means this is my x, image is my x, and what is y? Y is the folder name. That means x is my input and y is my output. That means this is my label. Okay, so x is the image. Okay, y is the label. Okay, label of that particular image. So this image is nothing but it's a dog image. That's how actually whenever you are giving cat image also, you are also giving the folder name. Okay, so this is the cat image. Okay, this is also y. So that's how actually it is picking up the label. Okay, it is picking up the label and it's trying to understand, okay, whether it's a dog image or whether it's a cat image, because again it's a supervised learning technique. Okay, you have to give the label of that particular image, and that's how actually we provide the label. Okay, in image classification. So we don't do the annotation here, we just create a separate folder. So let's say you have 5 different, let's say, object. Okay, you have 5 different images. Let's say you also have frog image. Okay, so what you will do here, you will be creating another folder called frog. Okay, frog. So inside that you will be keeping the frog images. Okay, so this is the idea only. Okay, that's how we can add so many label. Okay, as many label you can add here, you can add here. Okay, but I'm using only two label. One is like dog, another is like cat. Okay, so that's how you have to prepare the folder structure, and it will automatically pick up the folder name as the label. Okay, you have to remember in that way. All right, so this is the data structure, guys. So this data, now what I have to do, I have to upload in my Google Drive, because from the Google Drive itself I'll be reading my data. Okay, so what I can do, I can upload it quickly in my Google Drive. So I'll go to my Google Drive, and here I'll open it, and I'll upload this particular data here. Okay, and I will mount my Google Drive with my this one, Google Colab. Then I can access this particular data from here. Okay, I think it has uploaded. Now you can see here. Now what I have to do, I have to mount my Google Drive. Okay, so how to mount the Google Drive? So left hand side you will see the folder icon. Just click here, and after that you just need to click the third option called Mount Drive. Okay, if you just click on the Mount Drive, so it will connect with your Google Drive. Okay, now see it is mounting. So now let's connect. Now here you have to provide the account. So it will automatically mount. Okay, you don't need to provide the account if you have opened from the Google Drive itself. Let me change the view so that you can see everything here. Yeah. Okay, I think mount is done. Now if I cancel, now if I refresh, so I'll see the drive option. Okay, see drive is there. That means I am connected with my Google Drive. Okay, now I'll go to the folder. Okay, the folder actually I'm having my data. That means this particular folder location. So how to go? Just click on the drive, go to my drive. So I'm having so many files and folder in my Google Drive. That's why it will take some time. But if you have less files, so it will take less time. Okay, now see, this is my name. Inside that I'm having my YouTube live. Okay, so my classes, and here is the YouTube live. In the YouTube live folder, I'm having this CV hands-on. Okay, that means this particular folder. Now I'm inside this particular folder, CV hands-on. Okay, now I'll copy this particular folder location, copy path, and here I'm going to mention. Here I'm going to just write CD. That means change directory. Okay, change directory to this particular location. Okay, I want to go inside this particular location. Okay, that means currently if I show you my PWD, that means project working directory. So if I just write PWD, so I'm inside content. That means I'm inside my Google this one, Google Colab. Okay, Google Colab, let's say path, but I want to go inside this particular location in my Google Drive. So for this I need to change the directory. So this is the command. You just need to write CD, and you need to give the path of that particular folder. Okay, so this is the path you just need to copy, and here you have to paste. Okay, then once it's done, if I execute, now I will be able to see I'm inside this particular location. Now if I again copy this particular command and run it here, now you see I'm inside this particular location. Okay, I'm inside this particular location. Now I can minimize this particular screen. Okay, yeah. Now whatever content actually I'm having, I can also list down. So here I can write ls command to list down everything. See, I'm having this cat.zip. Okay, if I show you, this cat.zip is there, and I'm also having this particular notebook. Okay, IP1B file. Now what I have to do, I have to unzip this particular data. Okay, because inside that I'm having my data, right? So I have to unzip this particular like zip file. So to unzip that particular zip file, you just need to write one command called unzip. Okay, unzip, and you just need to give the name of this particular zip file. I'll copy this particular name, and here I need to paste it. Now if I perform the unzip operation, so it will unzip. See, unzip is going on. Yeah, unzip is done. Now if I go to my Google Drive and refresh the page, now you'll be able to see that yeah, this thing. The training folder is there. Now it will take some time to load all the folders and like you can say file. So please wait. Now again, if I perform ls operation here, I'll be able to see everything is created or not. Yeah, train and validation has came. Okay, that means I got all the folders. Okay, that means whatever folder I'm having in that particular zip file. Okay, now everything is came, right? See, this is my training image. Okay, inside that I'm having my cat and dog image, and I also having my validation image. Okay, now what I have to do, I have to import some of the library. Okay, to start with my image classification. Okay, so first of all I need, let me just import all the library one by one, just a minute. Yeah, okay, so first of all I need something called these are the library. So from TensorFlow, okay, dot keras, because I'm going to use keras. Okay, keras dot layers. I need some of the layers. Okay, layers, because what will happen actually, I'm going to download that particular pre-trained model, and at the last layer actually I'm going to add my custom layer. Okay, that's why I need this particular layer. Okay, I'll be using layer. So layers, I'm going to import first of all input layers. Okay, then I'm going to use also lambda. Then I'm also going to use dense layer. Okay, then I'm also going to use something called flatten layer. Okay, then I also need my model object. So for this actually I'm going to again write from TensorFlow. Okay, TensorFlow dot keras, okay, dot models, and import. I'm going to import this particular model object. Okay, model object, because I'm going to create my model. Okay, with my custom layer I will be adding. I'll tell you this part whenever I will be downloading that particular pre-trained model. Okay, then whenever I'll be adding the custom layer, at that time I'll tell you what is happening. Okay, then I also need something called the model. Actually I'm going to use here, so the model name is VG16. Okay, so this model is also already available inside Keras application. Okay, let me show you. If you search Keras application on Google, so you'll able to see this particular page. Okay, now here I'm having this particular model called VG16. Okay, not only VG16, you are having different model. Let's say exception model, VGC19, ResNet 50, ResNet 50 V2. Okay, mobile net, dense net, efficient net. Okay, then ConvNet large. So you are having different model with different size. Okay, as you can see, different size, and these are the accuracy of the model. Let's say you want let's say quick inference. Okay, from the model, at that time you can go with a smaller model, because smaller model will have lesser parameter. Okay, and you will get the quick inference. That means quick prediction. It will take less time to do the prediction. Okay, but let's say you want higher accuracy, but you are not worrying about the speed. At the time what you can do, you can go with the bigger model. Okay, you can see bigger model, whenever you will take, the size will increase, even the parameter size also will increase in the bigger model. Okay, and this is the time of the inference, okay, on the CPU and the GPU as well. So based on the time actually, okay, you can, and this is in millisecond. Okay, based on the time actually you can select the model. Let's say you need faster speed, at that time go with the smaller model, and whenever you need, let's say a higher accuracy, at the time go with a let's say higher speed model, that means the bigger model. Okay, that's how you have to select the model. But in this particular problem statement I'm going to use VG16 model, and this is the size of the model. This is the top accuracy. Okay, that means this is the accuracy they have trained on the ImageNet dataset. This is the benchmark accuracy they got. Okay, and this is the parameter size. Okay, and this is the depth. That means it is having 16 layer. Okay, 16 let's say convolutional layer in this particular model. Okay, and this is the time execution on the CPU machine, and this is the time execution on the GPU machine. Okay, 4.2 millisecond. Got it? That's how you can select the model. Now if you want to load this particular model, just click here, and here is the code snippet. Okay, you can use this particular code snippet to load this particular model. Okay, now let's load this particular model, and this model takes input size is equal to 224 3. This should be the image input. Okay, 224 3. Okay, now you can tell me I am having the image. Okay, it is not 224 3. Okay, if I show you the image resolution, it is less than, or let's say bigger than your 224. No need to worry. If you are using TensorFlow Keras, it will it will automatically take care. These are the let's say image resolution and all. Okay, let me show you the properties. Now if I go to the details, now see guys, this is the resolution of the image. Okay, now it is more than 224 3. Okay, now what I have to do, I have to resize this particular image with respect to my model input. For this I'm going to use some Keras preprocessing function, and I'll be doing. Okay, let me I'll show you this part. First of all, let me load this particular model. So let me load this particular model. So I'm going to open up my notebook. Now here I'm going to just write from TensorFlow. Then you have something called Keras. Okay, then you have something called application. Okay, because it is available inside application, I already showed you. And here you have something called VGZ model. Okay, VGZ16. Okay, now you need to import this particular VGZ16. Just write VGZ16. Okay, this particular model. So now I'm importing this particular VG16 model. Okay. Now let's see if you want to use any other model. Okay, just go to the model. Let's say I want to load this particular Resonate 50 model. I'll go. Only you just need to change this particular object. Okay, Resonate 50 object. Now if I show you here, okay, so here you will be writing something called Resonate. Okay, and here you will be using this particular object called Resonate 50. Okay, Resonate 50, Resonate 50. Okay, and here you also need to use Resonate 50. Okay, that's how you'll be loading. Okay, but I'm going to load VG16 model. Okay, that's how I'll be loading. Okay, then after that I need some Keras preprocessing function, so I'm going to also import. So from TensorFlow, okay, TensorFlow dot Keras, okay, dot preprocessing. Okay, I'm going to import image, because with the help of this image actually I'm going to perform the preprocessing image. Then I also need something called image generator. Okay, from the image. So what I can do, I can copy this particular statement, and here I can write dot image. Okay, and I'm going to import image generator. Okay, image data generator, and I also need something called load image method. Okay, so this thing I need. Then I also need to import something called sequential layer. Okay, so I'm going to call these particular things TensorFlow models. Okay, and I'm going to import sequential. Okay, then I also need numpy. So from import numpy as np. Okay, then I also need something called globe. Okay, so from globe. So these are the required library I need, okay, for my project. Okay, so that's why I'm importing everything all together. Globe. Okay, so whenever I'll be using, I'll be discussing, okay, why I'm using globe, why I'm using sequential, okay, why I'm using this particular load image, I'll be explaining later on. So these are the library I need to import. Okay, now let's import these are the library. Okay, so now it has successfully imported. Now what I have to do, I have to define my image size. Okay, I have to define my image size. So the image size, I think you saw, it should be 224, 3. Okay, but by default I'm using RGB images. Okay, as you can see, I'm using color images. Okay, and color images having 3 channel. Okay, that means green, blue, and red. Okay, 3 channel it will have. If I show you, so whenever you are using grayscale image, okay, grayscale image, in the grayscale image we will have only 1 channel. Okay, only 1 channel you will be having. Okay, this is the height. Okay, this is the height, this is the width. Okay, this is the width, and depth is like 1. Okay, only 1 depth you are having. But whenever I'm talking about color image, okay, color image, so here you are having 3 different channel. Okay, so one is like, first of all, red, green, blue. So red, then you have something called green, okay, or I can create like that, red, green, okay, and blue. Okay, so this is red, this is green, and this is blue. Okay, now this is the height, and this is the width. Okay, and this is the depth. Okay, you can see this particular thing is my depth. Okay, depth, and depth is like 3. So 1, 2, and 3 depth. Okay, this is called RGB image. Okay, that means color image. So we already know like our channel is 3. Okay, we don't need to mention the channel here because this is a color image. I only need to mention the height and width of the image. Okay, and the height of the image, width of the image, I already got to know. I'm using the VG16 model, and VG16 takes actually 224, 3 here in the description, in the argument input shape. Okay, it should be 224, 3. So let me set this particular parameter. So I'll open up my notebook, and here I'm going to write image size. Okay, image size, image underscore size. Okay, it should be equal to 224, 3. So let me just mention 224, 224. Okay, 224 comma 3 I don't need to mention because this is a colored image. Okay, I already know. Then I also need to mention my training image path. So train image. Okay, train path. is equal to, so here I need to give my path of the training image. Okay, so now if I do the ls, is you can see here, so this is my training image path. My training image is present inside this particular train, okay, train folder. So now let's copy the name. So this is the training image path. Okay, then I also need to mention my validation image. Okay, so let me copy, and here I can write my val path. Okay, valid image path. So it should be inside the validation folder. Okay, now let me define these are the variable. Okay, now I need to download the VG16 model. Okay, from the Keras application. As you can see, this model weight I have to download. How to download this particular model? The base model. So for this, just call this particular VG16. The VG16 we have imported here. I'll call this particular VG16. Okay, and inside that, first of all, you have to define the input shape. Okay, input shape, because it will take some of the arguments. As you can see, it will take the input shape, then weights. Okay, then it will also take classes. So these are the parameters it will take one by one, but you don't need to pass all the parameters. Some of the parameters you have to pass here. So first of all, you have to give the input shape. So let me give the input shape, input underscore shape. Okay, input shape is equal to, this is the image size I can take from here. So image size, okay, plus I can add 3 dimension with that. Okay, because what will happen, so let me show you. So if I add 3 here, it will give me that 224 comma 3. See, 224 comma 3. Okay, that's how actually I'm providing 224 comma 3. Okay, that's how I'm giving this particular image size. Okay, now here what will happen, I got my image size, that is input shape. Then I also need to mention the weight. Okay, weight is equal to, I want to download the image net weight. Okay, that means the pre-trained model. If you want to download the pre-trained model, you have to give the image net weight. Okay, image net weight. Okay, then after that, you have to write another parameter called include. Okay, include top underscore top is equal to false. Okay, you have to make it as false. Okay, why you have to make it as false? Let me discuss. Okay, so include. Okay, it should be false. It should be false. Yeah, I think it's fine. Now, if I execute, but before that, I need to also store this particular object in a variable. I'll just name it as VGC16 object. Okay, it's a VGC16 object. Now let me download. Now see, this model is downloading from this particular URL. Okay, now see, it's downloaded. Now let me comment out everything. So here I imported the library. Import package. Okay, then after that, I set constant. Okay, then I downloaded the model. Download VGC pre-trained model. Okay, pre-trained model. Okay, yeah. Now what is happening? So let me show you why I've given this include top is equal to false and how it is getting downloaded. Okay, so if I show you the VG16 architecture, okay, VG16, okay, architecture. So it is having 16 layer. Okay, let me show you. So it is having 16 layers. So for this, I'll take this particular image. Okay, I'll take this particular image. So I'll copy, and here I'm going to paste it. Okay, so this is the VG16 architecture. Okay, now here if you see, it is having 16 layer. Okay, so here is the 16 layer. Let me take a color. So you can see here, it is having 16 layer. Okay, so this is called actually conv layer. Okay, conv layer. That means convolutional layer. Okay, with the pooling and everything, we call it as conv layer. Okay, but you can see here, there is another layer actually I'm having called dense layer. This is called dense layer. Okay, that means your NN, that means artificial neural network. Okay, this layer actually called artificial neural network. We are calling it as a dense layer, and this layer actually we call it as conv layer. Okay, but whenever we download this particular model, so by default this model is already trained with ImageNet dataset. Okay, ImageNet dataset, and ImageNet is having, like, let's say if I show you the ImageNet data, ImageNet, okay, ImageNet data classes. Okay, ImageNet data classes. So it is having 1000 classes. Okay, see, 1000 classes. ImageNet is having 1000 classes. Okay, 1000 classes in that particular data. Let me show you. See, these are the 1000 example it is having. Okay, 1000. See, it has chicken, then it has a vehicle. Okay, so these are the 1000s labeled. Actually, they have trained with this particular model. But in this particular example, okay, in this particular project actually we are doing, we are only having two label. Okay, two label we are having, two label. Okay, one is like dog and this is like cat. But I can't use this particular last layer because it is having 1000. Okay, 1000 label. Okay, so what I have to do, I have to remove this particular last layer. Okay, I have to remove this particular last layer called dense layer. Okay, so if you want to remove it, so you have to write this particular statement called include top is equal to false. That's why, that means I'm telling to my model the top. Okay, the top actually layer actually you are having, which is nothing but dense layer. Okay, just try to remove it. Okay, that means false. Just try to make it as false. That means I don't want this particular layer. I only need this particular com layer because it will have the pre-trained weights. Okay, it will have the pre-trained weights, and if I have this particular weights, okay, I can easily train my model. Okay, now what I will do at the last layer, okay, at the last layer, instead of taking this particular dense layer, I'll be adding my custom dense layer here. I'll be adding my custom dense layer. Okay, so here I will add my custom dense layer, and here I will specify I'm having only two label. Okay, I'm having only two label in the last layer. Okay, so this is the idea. So whenever I will train my model, it will only train the last layer. Okay, last layer, and it will pick up your previous learning. That means this previous weight you are having in this particular com layer. Okay, so this is the complete idea to do this transfer learning operation. That means you are getting one pre-trained weights, you are removing that particular last layer, that means the dense layer, and you are adding your custom dense layer with the help of your number of label actually you are having, then you are training your model on top of it. Okay, so this is the complete idea. So that's why actually we have written this particular statement called include top is equal to false, and I want the weight of the ImageNet. Okay, yeah. Now what I have to do, I have downloaded the model. Now I have to freeze these are the weight, because I already told you I won't be training these are the weight of my comp layer. Okay, I have to freeze these are the weight. And if you want to freeze it, so what you have to write, so first of all you have to looping through all the weights. Okay, so here I can write for layers. Okay, for layer in VGG16 dot layers. Okay, VG16 dot layers. Now if I print all the layers, you will see it is having 16 layer. Okay, it is having 16 layer. All the 16 layer it will print one by one. See, it is having 16 layer. Okay, now I want to freeze them. Okay, that means I want to freeze all the weights. Okay, I don't want to train, only I will train the last layer. Okay, the custom layer actually I'll be adding. Now if you want to make it as freeze, so what you can do, I can copy this particular code snippet, and here I can mention. Okay, so here you just need to make this layer. Okay, layer. Okay, layer. There is a attribute you will get called trainable. Okay, trainable is equal to false. Okay, you need to make it as false. That's it. Okay, you need to make it as false. Now if I execute, so it will freeze all the weight. Okay, now if you want to verify, so what you can do, you can copy the same for loop. Okay, and here you can write print. So layer. Okay, layer dot name. Okay, and layer. Okay, layer dot trainable. Trainable. Okay, now if I print, you will see all the layer has been false. Okay, all the layer has been become false. That means I have freeze all the weight. I have freeze all the weight. Okay, now we have successfully freeze the weight. Now what I have to do, if I go to the model summary right now, so that means VG16 dot summary. Okay, summary of the model. So this is the entire summary of the model, like how many trainable parameters it is having. Okay, what is the input shape and all, everything it will show you. See, these are the total parameter, and trainable parameter is equal to 0 because I have made all the parameter as false. That means I have freeze all the weight. Now I'll adding my custom layer here. Okay, I'll be adding my custom layer. But before that, I need to load the number of classes actually I'm having in this particular folder. Like how many object we are having. I'm having two particular label, cat and dog. So if I want to get the number automatically, so what I will be doing, I'll be using this globe package. Okay, the globe actually I have imported. So here I already imported the globe. So this is the globe. I can copy the name. Okay, globe. Inside that you have to give the location. Okay, you have to give the location. So I'll give my train folder location. Okay, inside train I want to tell start. That means refer everything. Okay, now it will give me the folder. Okay, so it will give me the folder. Now I need to check the length of the folder. Now if I show you the folder, so here I'm having two folder. One is like cat and dog. Okay, cat and dog, as you can see, one is like cat and dog. Now what I will do, I'll check the length of this particular folder. Now you see, I'm having two classes. One is like cat and dog. Okay. Now I can automate this process, okay, to create my custom layer. Now I'll be adding my custom layer. Adding our custom dense layer. Okay. Adding our custom dense layer. So for this, first of all, I'll be defining my model called sequential. Okay, sequential, I think I already imported. Here I already imported sequential. Because it's a sequential model, okay? Sequence by sequence, you have to define everything. So sequential, then I have to add model.add. I'll add my base model. The base model actually we downloaded this VG16. Okay, VGC model. Then after that, I will add one flatten layer. Okay, model.add. I think we already imported flatten. Okay, flatten. Then after that, I need to add my dense layer. Okay, the custom dense layer. That means this particular layer actually I'm adding. Okay, my custom dense layer. So I'll be adding only two dense layers. So model.add. But in VG16 it was having three dense layer. Okay, but I'll be adding two dense layer here. You can add as many as layer you can. Okay, it's up to you. But I'll be adding two dense layer here. Okay, so dense. I already imported this particular dense. Okay, on top of. And in the dense, I want actually 256 neurons. Okay, 256 neurons. Okay, in this particular dense layer. And here I want to use activation function. Okay, activation function is equal to ReLU. Okay, ReLU. I think you already know what is ReLU activation function. Okay, then I'll use the same statement. And at the last layer, I'm going to add two only because I'm having two classes. Okay, as you can see, I'm having two classes, cat and dog. Okay, instead of giving two hard coded, what I can do, I can also give the length of the folder like that, but you can also mention two because you already got to know you have having two classes here. Okay, and at the last layer, activation function, I'm going to use softmax. Okay, softmax activation function because I have having more than one classes. Okay, that's how I'll be using softmax activation function. Now let me define my architecture. Now if I again do the model.summary, now you'll see the trainable parameter. Okay, you will see the trainable parameter. Yeah, so this is the model architecture right now, and this is the trainable parameter. Okay, so I can't the trainable parameter. Just a minute. Let me check. Okay, sorry, I have to write model.summary. Okay, I have written VGG16 summary. Okay, that's why it's giving me the previous object. Now you'll see the model.summary. You will see this is the trainable parameter. Okay, now this is the trainable parameter. That many parameter you have to train. Okay, now what I will do, I'll compile this particular model because in TensorFlow you have to compile the model. Okay, to compile the model, just write model.compile. Okay, model.compile, and inside that you have to mention the loss function. Okay, loss function. So loss is equal to, I'm going to use one loss function called categorical cross entropy. Okay, categorical cross entropy. This is the loss function I'm going to use. Then I also need to mention something called optimizer. Okay, optimizer. Okay, optimizer, because it will help me to do the gradient descent. Okay, that means the back propagation. So I'm going to use the Adam optimizer. Okay, there are so many optimizer. Stochastic gradient descent is there. Adam is there. Then you have ADA grade is also there. RMS prop is there. Okay, different optimizer are there. Then I also need to use the metric. Okay, so here I can write metric. Okay, metrics wise, I'm going to use the accuracy metric because this is a classification problem statement. Okay, that's why I'm going to use accuracy. Okay, accuracy metric. Okay, so now I'll be doing the compile of the model. Yeah, compilation is done. Now I have to load my image. Okay, I have to load my image because as you can see, the image actually I haven't loaded yet. Okay, and I also need to do some transformation on top of the image. Let's say I will be performing the scaling operation because if you know, image is nothing but it's a pixel. Okay, if I search any kinds of image, let's say image as pixel. Okay, pixel numbers. So if you see any image is a pixel numbers only. If I open any image, it's a pixel number only. See, it's a pixel number only. Okay, so this number actually, if you see, it's varying. Okay, sometimes it's a smaller number, sometimes it's a bigger number. Okay, and it will range between 0 to 0 to 255. Okay, this is the particular number. Now you have to scale those number. Okay, you have to bring in a one particular scale so that your back propagation, that means gradient descent, would be very fast. Okay, so for this you have to scale it. First of all, I will be importing one particular library. So here I can write image processing. Okay, now here I'll be importing one library from TensorFlow dot keras. Okay, dot preprocessing. Okay, image. I'm going to import this image generator. I think image generator we already imported here. Let me show you. Yeah, image generator I think we already imported. Yeah, I don't need to import. I already imported image generator. So I think I can remove it. Yeah, image generator I don't need. So first of all, I'll use this image generator object, and inside that I'm going to pass. Okay, I'm going to pass the scale parameter. Okay, the scale parameter. So here I can write rescale. Okay, rescale. C-E-L, rescale. C-A-L-E, rescale. Okay, rescale is equal to, you have to give 1 point divided by, okay, divided by 255. So here actually I'm performing min max scaling. Okay, and this is the number you have to give. Okay, if you want to perform min max scaling, okay, it will perform min max scaling for you. Then you also need to perform some image augmentation, because what happens actually, I'm having this very less number of images in the folder. I will be performing augmentation. That means I will be generating some new image. Okay, what is augmentation? Let me show you. So image augmentation. Okay, so augmentation is nothing but you are just using the same image sample and you are generating some image. Okay, let's say this is the cat image I'm having. So what I will do, I'll take this particular cat image, I'll rotate, I'll change the brightness. Okay, I'll cut this particular cat. Okay, I'll resize it. So that's how actually I'm generating new image. Okay, by referring the same image. Let's say I'm changing the brightness, contrast, okay, hue, saturation, and all. So this is called image augmentation. Okay, and if you want to perform image augmentation in runtime, you can also do it with the help of this image generator. Okay, now inside that you have to perform some of the parameter. Let me show you. So these are the parameter you have to mention. So share ratio, that means it will perform share. That means it will rotate this particular image. Okay, so here, so this is called sharing. Actually, this will rotate this particular image. This is called sharing. Then zoom range, that means sometimes it will also zoom that particular image. Let's say this is the image, sometimes it will zoom that particular image. Okay, so this is the zoom range. And you also need to give the horizontal flip. That means it will also perform the flip operation. Let's say this is the original image. After flipping, actually it will look like that. So let me show you one flipping example. Yeah, so here I can show, let's say this is the original image. After flipping, it will look like that. Okay, so you also need to set the flipping parameter. There are so many actually things in the image augmentation. You can write keras image augmentation. Okay, so you will already get all the functionality. See, random crop you can apply, flip you can apply, translation you can apply, rotation you can apply, zoom, contrast, brightness. And here is the code, guys. Okay, if I click here, so here is the code. Okay, how to apply, these are the thing. Here is the code. You can apply, you can explore later on thing, but here I'll be applying these are the things only. Okay, now it will give me my training image. Okay, my training data generator. So here I can store it, this particular object, training data generator. Okay, now similar wise I also need to perform for my testing. Okay, so here see, testing I don't need, because training, in the training itself I will be only doing the data augmentation. Okay, but in the testing image I will only apply the rescale operation. So what I will do, I'll copy, and rescale I will only apply. Okay, and I think I'll close the bracket. Rescale is fine for me. Now let me also change this is the testing image. Okay, test image, test data gen. Okay, now let me load this particular object. Okay, now what I have to do, I have to load this particular image, because I already created the object. Let's say what are the transformation I'll be applying. So instead of image processing, I can write data transformation. Now I have to load the image. Okay, load the image from the directory. So loading images. Okay, So how to load the image? So first of all, I will call train data gen, and inside that you have one like method called flow from directory. Okay, that means it is available inside my directory. Okay, let me show you. So if I just write ls, it is available inside my directory. So it is available inside my directory. Okay, training directory and validation directory. Okay, so I need to give this particular directory location. So flow from directory, and here you have to give the directory. So it is inside my training folder. Okay, training folder. Okay, then I don't need to give the path. Only training folder is fine. Okay, yeah. So I need to give enter. Just a minute. So this is inside my train. Okay, then I also need to give the input size. That means the model input size is 224 comma 3. Okay, and your image should be also converted to 224 comma 3. That's why you also need to mention the target size of the image. So it will automatically crop this part of the image, okay, for you. So you don't need to manually do it. Then you also need to give the batch size. Okay, because during training, how many batches actually it will take the image. Okay, then you also need to give the class mode is equal to category, because it's a categorical classification I am doing, not a regression. Okay, it's a categorical classification I'm doing. Now I already given my generator. Now it will give me my training set. I'll get my training set. Okay, training set. Now I also need to load my testing set as well. Okay, so first of all, let's load the training set. Loading training images. Okay, train images. Now let me load. See, found 333 images belonging to two classes, because it is referring my training, okay, training folder as well as the validation folder, and it is combining all the images together, and it is telling that many of images it is found. Okay, then I also need to load my testing image. I'll copy the same code, and here I'm going to mention, and here I'm going to mention is the testing image. Okay, so for testing image, here I can write this is a test set. Okay, and I'm going to use the same test gen right now, because train gen I have loaded. Here I can write test gen, because this is my testing image. Okay, testing image generation. Now test gen flow from directory. Okay, and here you have to give the target size, batch size is equal to, and the class mode. Okay, so everything you have to give like that. Now let's load the testing image as well. So I'll load the testing image. Now testing image wise, it got 333 images belonging to two classes. Okay, it's completely fine. Let me verify once again. So everything is fine or not. Test gen. Okay, it is coming the same image. Why? Just okay. Sorry, I'm giving training folder, so it should be testing folder. Sorry, validation folder. Otherwise, it is loading my data from the training image. Okay, that's why you need to give the validation folder, because this is the testing image. Okay, now I think it should work. Where I have given? Sorry, not here. I have to given here validation. Here I have to give. Okay, now let's load the training. First of all, yeah, compilation is done. Now let's load the training image. First of all, let me define that data gen again. Then load that. Then I also load my testing image. Okay, now see, testing image, it got 59 images only belonging to two classes. Okay, everything is fine. Now I'll start the training. To start the training, what you have to do, just write model dot fit. Okay, and inside that you have to give the training set. Okay, so I am having the training set here. So this is the training set, training data. Then you also need to give the validation set. Okay, validation underscore data is equal to, here is the validation set. That's been testing set, validation set. Okay, then you also need to give the epoch, number of epoch you want to train. So epochs. Okay, epochs is equal to, I want to only 10 epochs, or you can also increase the size. That's 50 epochs. Okay, 50 epochs at least. But whenever you are training your actual model, make sure you are increasing the epoch size. Okay, otherwise your model won't be learning better. Okay, then I also need to give my step per epoch length and validation step per epoch length. Okay, so you can give like that. So these are the default parameter you need to pass inside the model.fit. Okay, step per epoch and validation step per epoch. For this, you can take the length of the training set, and you can take the length of the validation set. Okay, that's it. Now you can start the training. So let's start the training. But before that, I will also want to store my model training object in a variable. So here I can just write, I can store in a, let's say, variable. So here I can write history. Okay, history. Okay, so this is my variable. Now here I can execute. See guys, my epoch has started. Now it will train 50 epoch, and you can see the accuracy and losses. Okay, see loss and accuracy, you can see real time. So let's wait. Okay, it will take some time. So this is my training accuracy, training loss. This is my validation loss. This is my validation accuracy. And see, it is learning, I think. So we can check here. See, initially it was 49. Now it has become validation accuracy has become 76, 79, 81, 81. That means it is learning. Okay, it is learning better. And if you can observe, your accuracy is not increasing, loss is not decreasing, at the time you can stop the execution. Okay, but you can see my learning is going on. And see, accuracy, training accuracy and validation accuracy should be close together, otherwise your model will be overfitted. Okay, make sure this two accuracy and losses is close together. You can see my accuracy is 97 and validation accuracy 83. It's fine, I can call it, it's learning. But if there is a huge difference, okay, that time you can consider it's a overfitting problem. My loss is decreasing, accuracy also increasing sometimes, and sometimes decreasing because it is learning right now. Again, you don't have let's say huge amount of data, that's why learning is not good. So you have to add more images here. I only trained how many images, guys? So here is the image size 168, so it's not enough. At least you should have 1,000 example, okay, in each category. So 28 epoch is going on. So let's wait for 50 epochs only. Okay, after that I think we can show you. Can we use LLM for image classification? LLM, again, see, in LLM actually you have two kinds of LLM. You have LLM, that means large language model, and you have something called LIM, that means large image model. Okay, large image model can only generate image. Okay, not it can't actually do the image classification. It can perform image classification. Let's say if you give one image and you can give a prompt, let's say which object present in the image, it will tell you that particular object. But image classification is a separate thing we need. Okay, so I always tell, let's say you can let's say kill one bird with the help of, let's say what with a stone actually. But why you will be using, let's say, rocket launcher for this? Okay, so it's kinds of thing like that only. So you can solve this problem statement with the help of simple architecture, let's say BG16 revision 50. But why you will be using LLM there? Because LLM would be very like costly now at the end. See, my accuracy is not improving. That means I can stop the execution right now, but let's wait at least 50 epochs. I already done. Okay, it's done. Now I can show you the graph, actually loss and accuracy graph. So for this, I can use something called matplotlib. Okay, so import. You can also use Seaborn, but I will be using matplotlib. So matplotlib dot pyplot, okay, as plt. Then I can just write, first of all, let me import. Yeah, so I can just write plt dot plot Okay, plt.plot. First of all, I want to plot my history. Okay, dot history, because it is having one method called history. Okay, so let me show you. The history object actually I stored here. Okay, history, it is having another object called history, and in that particular history I'm having all the matrices. Okay, in a CSV file. Let me show you in a table actually. So history dot history, if I just do, so it will show you one table. Okay, so it should be attribute only. See guys, it will give you all the metrics and losses. Okay, all the metrics. See, this is the loss and this is the accuracy. Okay, everything it will give you. Now this thing I want to plot. Okay, how I want to plot? So I'll be using plt.plot. I want to plot history. First of all, I want to plot the loss. Okay, so here I can give, I want to plot the loss, because as you can see, it is having also losses and accuracy. Okay, losses and accuracy. So I think somewhere I saw the loss. See, this is the accuracy and this is the loss. I think this is the loss. Okay, I want to plot the loss first of all. So let's plot the loss. Then I also need to give the label. Label is equal to, this is my train loss. Okay, this is my train loss. Okay, then I also need to plot my validation loss. Okay, so for this I'm going to use the same code, plt.plot. Now history.history, here I'm going to write my validation loss. Okay, val loss, val underscore loss. Okay, now label should be validation loss, val loss. Okay, then I want to create a legend. So for this, plt.legend. Okay, legend, legend, legend. Then after that, I will get to show this particular image in my Jupyter notebook. So I'll just write plt.show. Okay, then I also need to save this particular file. Okay, in a PNG file. So for in a JPG file or PNG file, you can also save. So for this, you can write plt.save file, save file. Okay, and here you can give any name. So it is my loss val graph. Okay, loss okay, loss graph. It's my loss graph. Okay, here I can save like that. Now let me execute and show you. Okay, save file is not there. I think save fig. Okay, it's a save fig, not a file. It's a save fig. I want to save the figure. Okay, now you can see this is the loss. That means your training epoch is increasing. Your loss is also decreasing. Okay, loss is also decreasing, but here is the saturation, as you can see. But I already told you, you don't need to train that much of epoch. Here I got my lesser loss, but again, this is your validation loss. You can see this is the val loss, this is the training loss, and it is like slightly difference because again you have less amount of data. That's why you can see this. These are the difference. Okay, but if you're having, let's say, a huge amount of data, and at the time you will see these two losses would be close together. Okay, that time your model is learning. I can't tell this model is better, but at least I showed you the training. But later on, you just download that particular image I showed you from the Kaggle. Okay, use all the data and now train the model. Okay, you will see your model will be learning better. Okay, so this is the loss graph, and this image actually I have also saved. Okay, now if I go to my drive and refresh the page, now see this loss graph also I have saved. Okay, this is the image I also saved in my Google Drive. Okay, now we can also refer later on. Okay, so you can download and you can see that I already saved this. Now what I have to do, yeah, now what I have to do, I also need to show you the accuracy. Okay, accuracy graph. So accuracy wise, I can use the same thing. Only I just need to use the accuracy. Okay, instead of loss, it should be accuracy. Okay, accuracy, and this is my training accuracy. Okay, as well as my validation accuracy. My accuracy, and everything will remain same, and this should be my accuracy graph. Okay, now let me execute. Now see guys, this is the accuracy. That means epoch is increasing, accuracy is also increasing. But again, you can see the difference because I have by less amount of data. Okay. Now what I have to do, I have to save this particular model. Okay. How to save the model so that you can do the inference later on. You can create an application later on. So here I can write save model. Save model. Okay. So to save the model, you have to use something called you have to use something called model dot save. Okay, this is the method you have to use, and inside that you have to give the model name. So I can save the model with the help of this particular name, model underscore VGG16. Okay, VGG16 dot h5. Okay, if you're using TensorFlow, you have to use this particular format called h5. But if you're using PyTorch, you need to give pt.pt. Okay, so this is the difference only. Now let me save the model. My model is saved. Now if I go to the drive and refresh the page, now after some times you'll see it will load. See guys, model has been saved. Okay, now I'll tell you how we can load the model as well. Okay, how we can load the model as well. So first of all, yeah, so to load the model, you have to use this particular load method. Okay, so you just first of all need to import this particular load method from the TensorFlow. So here I can write load model. So for this you need this particular load method from the TensorFlow. So TensorFlow, okay, TensorFlow dot keras, okay, models import load underscore model. Okay, load model, and inside load model, here you need to pass this. So model is equal to load model, and this is the name. Okay, the name actually you have saved the model, you have to give the same name. Okay, now it will load the model. Okay, it has loaded the model. Now I want to do the prediction. Okay, on top of my test data. So what I can do, I can also do the prediction. I can just write model dot predict. Okay, model dot predict, and here I can pass my test data. Okay, test set. Okay, test set actually I loaded. So test underscore set. Okay, now it will give me the prediction. That means y hat. So here I can write y pred. Okay, y prediction. So let me predict. Okay, now here I got all the prediction, and it is in softmax output. See, it is in softmax output. Okay, that means true probability I'm getting. So highest probability should be my actual answer. Now how to filter out the actual answer? Okay, so for this you have to use numpy. So I already imported numpy. So here you just need to write np.argmax. Okay, with the help of argmax you can solve this problem. So argmax. Okay, inside that you need to give the y prediction. Okay, the y prediction you got. Okay, and you need to define the axis. Okay, as axis is equal to 1, and after that it will give you the y pred again, y underscore pred. Okay, now if I print it, now see I will get my 0 and 1. Okay, 0 and 1. That means whenever you are having 0, okay, whenever you are having 0, that means it's a, whenever you are having let's say 0, it's a cat, or whenever you are having 1, that means it's a dog. But how I will get to know whether my 0 is cat and 1 is dog? Okay, for this you have to check the this one actually. If I go to the folder, okay, if I go to the folder, now you can check the alphabetically order. Okay, now see cat. Okay, cat is coming because if you see the C alphabet, okay, C alphabet, C, after C actually D come. Okay, so if I now assign the index, okay, if I assign the index between these two folder, so C will have the 0 index and D will have the 1. Okay, that's how actually by default your keras will also consider. C will be assigned with 0, that means cat will assign it with 0, and D will be assigned, that means dog will be assigned with 1. Okay, so that's how whenever your model is predicting, whenever your model is predicting 0, that means it is predicting as cat. Okay, and whenever it is predicting as 1, that means it is a dog. Okay, that's how we can define this particular label. Okay, now what I will do, now I need to, so this is my prediction. Okay, this is my final prediction. Now let's say you want to do a single image prediction. Okay, you can also do the single image prediction. So let me show you how to perform the single image prediction as well. So first of all, let's load upload one image here. Okay, in my directory I'll upload one test image. Okay, so I'll upload one cat image. Let's upload one dog image first of all. So this is a dog. Here is the dog I can see. Let me upload one dog. Let's say this is the dog. Okay, this is the dog. I'll upload this particular image. I'll copy, or I can drag and drop here. Okay, this is my dog image. Now, first of all, let's load this particular image. Okay, to load this particular image, I think you remember, we can also use a matplotlib to show the image. Okay, let me show you. Just a minute. First of all, let's load the image. So load our testing image. Load test image. Okay. So what is the name of the test image? So here I can take the name ls. So here is the name of the image. Okay. So image name. This is the image name. Now I can load the image with the help of the image library we have imported. Let me show you. So here we have imported the image, I think, somewhere. Yeah, image I imported. So here I imported the image. Okay, I'll copy this particular library. And here I can use image. Okay, image dot load. Okay, load. Okay, load image, I think. Load img. Load underscore img. Okay. Now inside that you have to give the name of the image. So this is the image name. Okay. Then you also need to define the target size. Okay, the same target size you train the model. Okay, 224, 224. So it will load with respect to that only. Now it will give you the image object. img. Okay, image object. Now let me load the image. Okay. Then after that you have to convert it to numpy array. Okay, this image actually you have to convert it to numpy array. Okay, and this will give you the numpy array. Now see guys, this is my pixel value, okay, of that particular image. Now if you want to like show it, okay, like how this images look like, you can use plt.show. Okay, sorry, it should be image name. Now it should show. So this is my dog image. Okay, now what I will do, I'll see the shape of the particular image. Okay, x.shape. So it's 224, 224, comma 3. Okay, now I have to apply the scaling operation. I think you remember we also perform scaling operation during training. Okay, the min max scaling. I need to divide with 255. Then I need to process the input because I need to add one batch dimension here. Okay, that's why I'm going to use this process input function. Now here you can set the batch dimension like that. Let me show you. Okay, I'm expanding one dimension here. Okay, because what is happened by default, if you see, it is the dimension of the image. Okay, but when we train, there is another dimension called batch dimension. Okay, but this image doesn't have any batch dimension. That's why I'm adding one batch dimension. Okay, one extra dimension. So now if you see my final dimension, it's 1. That means one batch. That means one image I'm having, which is nothing but 224, 224, comma 3. Okay, 224 is a height, 224 is a width, and 3 is the channel. Okay, then finally I can give it to my model. So model dot predict. Okay, model dot predict, and here is my data, my image. Okay, now it will give you the prediction, but again it's a sort max output. Okay, but if I want to get an authentic output, that means 0 or 1, at that time I can use argmax. Okay, argmax, inside that I can do it and it will give me the result. Now if I show you the result, now it is predicting as 0. Okay, it is predicting as 0. Now what is 0 means, guys? 0 means it's a cat, but my model is failing. Okay, in this particular case, now see, it is predicting as cat. Whenever it is let's say 1, it's a dog, other is a cat, but here it is predicting as 0. That means my model is not a good model because we have very less amount of image. Okay, that's why it's not predicting. So now what you can do, you can try with a cat image also. So let's upload one cat image. I think cat image, I think it should predict. So let me try. Let's say I am having one cat image here. So this is the cat image. So I'll be using this particular image. Okay, now let's load this particular cat image also. So here is the cat image. Let's load quickly. Now see, cat, it is predicting correctly, okay, but dog, it is not able to identify because maybe you have to add some more dog images, okay, then it will work fine. Okay, now see, cat, it is working fine. Okay, now see, that's how you can also do the image prediction. Okay, if you have any single image, you can also do the image prediction. Okay, now you have your model. Okay, you have your model, and you already know how to, let's say, test on top of the model, how to load the model, okay, how to upload an image. Now what you can do, you can create a web application right now. Okay, you can create a web application. There user will upload one image. Okay, he will receive that particular image and he will perform these at the operation and will show the prediction whether it's a cat and dog image. Okay, that's how we can do. Okay, so this should be your task. Just try to create a web application with the help of Flask or Streamlit. You can create. Okay, that's how actually you can create an application on top of it. But I have showed you the entire step, how we can prepare the data, how we can training and all. Okay, and how we can perform the image classification technique. Okay, see, on top of image classification, I implemented one package called image seeker. Okay, long back. So if you don't know about coding and all, if you are worrying about the coding, so you can use my package. Okay, image seeker package. So you don't need to write any code for the image classification. So this is the PyPy package I developed. So the author is me, Bappi Ahmed, and this is the repo of this particular PyPy package. So 2 years back, actually, I implemented this. 3 years back, okay, I implemented this particular package, and this package tell you, see, these are the steps actually we performed so far to perform the image classification. Okay, but if you're using my package, what you have to do, only you just need to create an environment, install image seeker. After that, launch the image seeker. Okay, you will get this kinds of interface, and here you just need to click on the get started, give your data location, number of classes, model name, which model you want to use, choose the model, number of classes you need to give. After that, click on start training. Okay, it will automatically train. After that, you will see all the graphics, metrics and everything. Then after that, you need to click on the predict button. Then you will get this kinds of interface. Okay, now if you upload any image and click on the predict, it will show you whether it's a cat and dog. Okay, so this is the class, like image classification library I developed long back. Okay, then on top of that, I think I already added one YouTube tutorial how to use this image classification. Now let me show you the YouTube tutorial as well. So it is available in my YouTube channel. So if you go to my YouTube channel, so this is my YouTube channel. So in the video section, I think you will see that image seeker. Okay, you can search on the search button. There is a search button you will see. You can search here called image seeker. You will get this particular thing. So this is my YouTube channel. Okay, so that's how, guys, you can also work on, you can automate this particular task. Okay, if you want, and you can build something for the community. Okay.